This is problem number 7 from section 9.1. In this problem, it says approximate graphically the radius and height of a cylindrical container with volume 50 cubic inches and lateral surface area 85 square inches. So this equation right here represents our lateral surface area, and this shape, and this shape represents our volume. So let's go ahead and write out our equations in it. It says volume of a cylinder equals pi r squared h. So we know the volume is 50, so we have one equation that's 50 equals pi r squared h, and we have another one that is lateral area of a cylinder, which is 85 equals 2 pi rh. Now notice that in one equation we've got r squared, and in the other equation we have r. If we're going to solve this graphically, which they said here, we probably want to solve each equation for a variable, and we want to solve it for the same variable. So let's solve this equation. I think because we see r squared and r here, we want to actually solve the equation for h in each equation. So let's go ahead and divide by pi r squared. So we end up with 50 over pi r squared equals h when we divide each side by pi r squared. And then we're going to divide this side here by 2 pi r. So we end up with 85 over 2 pi r equals h. So now that we have both of those written there, we can start to use our calculator to graph these two things. So let's go ahead and graph the first one. So we'll go to y equals, and we'll say that, and we're going to have to define that our y value here is actually h. So y is going to equal h, and x is going to equal r. That's something very important to see here, because when we graph these two things, we're going to need to pay attention to those two variables. So we're going to say 50. Actually, I'll put this in a fraction mode. So 50 over pi. So over pi r, which in our case, we're going to use x. So x squared. And then we're going to go down here and we're going to say that this is 85. Again, use a fraction. So 85 over 2 pi. And then we're going to use x again for r. Now let's make sure our window's set okay. Looks like our window's set at -10, 10, 1, -10. I think we'll start with this window. I always like to start from -10 to 10, going by ones for each, and see where this graph takes us. Okay, if you notice, looks like we're intersecting up here in the first quadrant. So actually, I'm going to go back to our window, and I'm going to change this window value. I want to go, for our x min, I'm going to make this 0. For our y min, I'm going to make this 0. And our x max, I'm going to leave at 10, but our y max, I'm going to make 20, that way we can see it. And now let's graph it. So now we're just in the first quadrant here. And you can see we have an intersection right there, which is where our solution is going to lie. So here's what we'll do. We'll go and we'll use this calc button, second calc, and we'll find the intersection between the two lines. So we can click on the intersect button. And then it's going to ask us which line. So for the first curve, we want this line. So we'll just hit blue as the first. That's the second. And guess it. and it says the gas, error, no sign change. So it said error, no sign change because, let's go back to graph, we didn't go across that little point there. So let's do that again. We're going to go to calc, we're going to go to intersect. I'm going to click the blue line, but now for the red line, I'm going to slide over until I'm across the intersection point. So I got one mark on one side, one mark on the other. Let's guess it. Intersection point, there we go, and you can see it went straight to that intersection point. It tells us that our x value or our r value is 1.176, and then and remember this is talking about inches, so this would be inches, and our h value, which is y, is 11.499 inches. So when we solved this graphically, we found that our r value for this cylinder is 1.176 inches, and our h value is 11.499 inches. So the radius here is 1.1, and the height is about 11.5 inches. I hope that makes sense how we did that and solved it graphically. We just looked for the intersection point after we plugged in our values for the volume and the lateral area.